So up until this point, we have done pretty basic integration. We can do all of the things on the left side without what is called the chain rule, okay? We can take a derivative of x and a derivative of this 1 here. We can take a derivative of sine. We can take a derivative, like all of this we can do without the chain rule. But over here, we start running into issues. Not only do we have this x squared plus 1, but we also have the square root of this group. Not only do we have a sine, but we have this 6x we have to contend with. Not only do we have 3x plus 2, but that whole group is taken to the 5th power. We have a tangent, but this x squared is a group in and of itself. So what you'll start to see is these are types of composite functions, right? This is a function within a function, right? This guy is a function within a function. A function within a function. So you start to have composite functions where you have two things. You have a square root and an x squared plus 1. All right? And when you start doing composite functions, you have to break them down. And we use what's called the chain rule. All right, so with the chain rule, they have this whole theorem. If y is the function of u, another function, and it's differentiable, where u is another function like g of x, and then that is also differentiable, then f of g of x, or that composite, is differentiated like this. dy dx is going to equal dy du times du dx. All right, this is how I describe it. The derivative of the outside times the derivative of the inside. Okay, that's what all those words mean. So if you have a composite function, you take the derivative of the outside and you multiply it by the derivative of the inside. Okay, let's see how this works. All right, so first of all, what are my functions? Well, if I looked at something like this is a function, and it is in a 1 over, it's in a reciprocal position. If I look at this guy, I have a 2x that is inside a sine. So you start to see the complicated pieces of it here. If I see this function that is inside this function. All right? And so when you start to have compositions of functions, you have to know how to decompose those, how to break those down. So let's look at example 3. They want the derivative of x squared plus 1 cubed. All right? So we are going to do the derivative of the outside, and we are going to multiply it by the derivative of the inside. The outside is that group cubed. So we're going to ignore what's inside it, and we're going to treat that group as though it was just its own little unit. So if I'm taking this derivative, I want the derivative of the outside. So I'm going to leave the inside alone. It was a 3. What do I do with that 3 according to my exponent rule? I bring it over here. What's my new exponent? There we go. That's the derivative of the outside. And then I am going to multiply it by the derivative of the inside. What is the derivative of x squared plus 1? 2x. And then I want to simplify it. The way I would simplify this, I would not FOIL it, by the way, but I would multiply this 3 and this 2x. And then I would just leave this alone. The only reason I would do anything else with that is if I needed to do something going forward. Like I was finding the derivative to then do something with it. If I'm not going to do something with it, I'm going to leave my answer just like that. 6x times x squared plus 1 quantity squared. That would be using the chain rule. So what we just did was the general power rule. You're going to treat it just the same. You're going to put the exponent on the outside, drop your exponent by 1, then take the derivative of the inside. All right, that is the general power rule. So let's look at the next couple of examples. How would I do this then? Well, if I want to find my derivative of the outside, I leave this alone. Bring this 3 in front, drop that to a 2. I am going to multiply that by the derivative of the inside. What is the derivative of the inside? 3 minus 4x. Now, again, I would probably, they didn't change it around. I would probably do my lowest exponent to my highest, but it actually doesn't change anything here. I would not FOIL or distribute here. I would just leave it alone. Unless, like I said, unless I were using that to simplify further. Like if I were doing this and a quotient rule and this were my numerator, I would simplify it. But if I'm not doing this in a quotient rule or something, then I wouldn't worry about it. All right. So this would be my derivative right here. All right, so let's talk about it when we have points on the graph that involve radicals. Now, specifically, this is asking a question. This says, find all points on the graph of f of x equals cubed root of x squared minus 1 squared, for which the derivative equals 0, and those for which it does not exist, okay? So they actually are asking us to do a couple of things. First, we have to find the derivative, because they specifically want where this derivative is 0, and they want where the derivative is undefined, okay? In order to tell them that, I have to find the derivative. So what we're going to do is we're going to rewrite this in exponential form, all right? This is a radical. So how would we rewrite this radical in exponential form? I don't want it in radical form. I want it in exponential form. How would I write it? X squared minus 1 to the what? To what power?
To the 1/3?
Not quite. We have an exponent. We have an exponent that needs to be our numerator. Not to the 1/3, but to what? This is my numerator. This is my denominator. All right. So now when you rewrite the radical, you can see how you could do chain rule, right? So I could say, well, my derivative then is going to be 2/3 x squared minus 1 to the negative 1/3 times 2x. I need to simplify this, all right? What goes on top? My 2 and my 2x, right? So I have 4x over, on the bottom I have a 3, and I also have the cubed root of x squared minus 1. All right? So where would this be? We want two things. They said first we want to know where this guy is 0. How do I figure out where a fraction is 0? When which piece of it is 0? The denominator makes it undefined if it's 0. Where is the function equal to 0? Yeah, if it's 0 divided by something, then your answer is 0. If it's something divided by 0, your answer is undefined. They've asked for both of those. They've asked for where it equals 0 and where it's undefined. So where it equals 0 is going to be where my numerator equals 0. Where does my numerator equal 0? At 0. So this is where f of derivative of x equals 0 at x equals 0. All right? Where does it not exist? Well, it's going to not exist where my denominator is 0, correct? Now, if this were not a cubed root, I would have to worry about one other limitation on that. What would it be if that were a square root, not a cube? Yeah, a negative, but it is a cube, so it can be negative, all right? So this 3 will never be 0, but I have to make sure this guy's not 0. There's two places. F first root of x is undefined. Where are the two places that make that denominator 0? At x equals what? This guy can't be 0. 1 and? All right. So they wanted us to do multiple things. We had to do the chain rule first to find first derivative. Then we had to figure out where it equals 0 and where it was undefined. All right. So they asked for it multiple ways, but they're asking for us to do the same thing. All right. Find your derivative here. I just want the derivative. The other thing we're going to talk about is rewriting it when it's in the denominator, okay? So this is technically the chain rule, but you do not have to use, we're going to move to where we have to do chain rule plus quotient rule, chain rule plus product rule, right? But this one's not one of them because I just have a constant on top. So if I wanted to do this one, I would actually just rewrite it. I would say, instead of writing it this way, I'm going to say negative 7 times 2t minus 3 to the negative 2, right? And then I'm going to perform the chain rule. I'm going to multiply by negative 2 and negative 7 to get positive 14. 2t minus 3 to what power? Yeah, negative 3. And then I still need to multiply by derivative of the inside. So then my final answer here is going to be 28 over 2t minus 3 to the third power. All right. If I wanted to know where this one is 0, it's never 0, by the way, because 28 can never be 0. If I wanted to know it was undefined, I would set the denominator equal to 0, right? Positive 3/2. Okay, so if they asked that same question like they did before, you would do the same process, okay? Because we're actually going to use that concept. All right, do one more for me.